The sum of the exterior angles of any simple polygon is 360 degrees. Hey, what's up everyone? Welcome to today's episode of Christian Relearns Math. And today we're going to go through the intuition for why that is true. Why are the exterior angles of any simple polygon, the sum of those, why is that 360 degrees? So first let's think about an exterior angle. So let's say we have a polygon here, and we have a triangle. So let's say we extend one of the sides here a little bit. So an exterior angle, all that means is we're talking about the angle between extending one of the sides. So this is an extension of the straight line here that makes up that side, and the adjacent side. So when we say an exterior angle, we're talking about this angle here, the angle between extending one of the sides and the adjacent side. So let's write that down here, exterior angle. And that is in contrast to this one here. So this is between two adjacent sides of a triangle. And this one here is interior. And you can see that's where the names come from, right? So this is the interior angle, and that is the exterior angle. And also notice that the two of them together sum to a straight line, to 180 degrees. So here we have our polygon. In this case, it's a triangle. And you can see we've extended each of the sides in order to form those exterior angles. Now, the visualization that I really love for this, and it has helped me enormously, is imagine that you're at school at a playground and you have drawn this figure on the ground in chalk, in very large size, huge size. And you're going to start at a corner. Let's say you're going to start at point A, and you're going to walk around the perimeter of this triangle. But you're also going to hold your arm out in front of you, straight in front of you. Your arm always has to be straight in front of you as you walk around the perimeter of this triangle. So initially, when you start, let's say that you are facing this direction here. So your arm is pointing along this extended side here. So for you to walk around the perimeter of the triangle, what do you have to do? Well, you have to turn. And the way that you're going to turn, it doesn't actually matter which direction you turn, both of them work. But for us, we're going to go this way because that's the sides that we've extended. So you're going to turn initially, and the way you're going to turn is this direction. So your arm, which was pointed that way, your arm has now turned, and now it's pointed this way. And so you're still standing here, but your arm is pointed towards point B over here. And so what do? Well, then you walk. You walk along and you get to point B. Your arm is still pointed in that direction, okay? But you want to walk around the perimeter of the triangle. So what do? Well, you turn. And remember, your arm always has to stay pointed straight in front of you. You can't move your arm in different angles. After you turn, your arm is pointed this way. It's pointed towards point C. Okay, so what do? Well, then you walk along this side towards point C. And now your arm, now it's pointed this way. Okay, so what do? Well, to get to point A, you have to turn again. So you turn that way. Your arm is now pointed here, so what do? Well, you walk back to point A. Now here's the critical part. Notice, what direction is your arm pointed in? It's pointed in the same direction that it started. Now, if we think about these angles that we made from turning, which angles were they? Well, it was this one here, that first angle, this one here, that second angle, and this one here, that third angle. What does that tell us exactly? The critical insight here is that the sum of all of these angles, remember that we ended in the same direction that we started in. And because of that, because we ended in the same direction that we started in, that means that the sum of all of these angles that make up all of the turns that we made, the sum of all of those will equal one full rotation, or one circle. And why? Because we ended in the same direction. We ended pointed in the same direction that we started in. So one full rotation, or 360 degrees. Now we can see that also if we put in our angle measures here. Now notice here too that if we put our colored angles back, we can actually trace over them freehand and make a circle. Let's try to do that here. Okay, there's our green angle. Here is our red angle. And here is our purple angle. And let's color these. There's our red one. We'll line it up there. Here is our purple one. We'll line it up there. Okay, not too bad. You can see here that they do indeed sum to a circle. They sum to 360 degrees. Now it doesn't have to be a triangle. The exterior angles will always add to 360 for any simple polygon. And in fact, I highly encourage you to sketch this out. You don't have to use fancy software like this. Highly encourage you to sketch it out simply on pen or paper or a whiteboard or anything like that. I know I've done that myself and it's extremely helpful. So for example, let's do a hexagon here, right? So we'll do this freehand. So here is our hexagon. Okay, you can see, yeah, it's not perfect. All right, that's fine. And then let's extend the sides of our hexagon here. Okay. So now we've extended all of the sides, and let's pick a point. It can be any of the points of this hexagon. Okay, so let's say this one. So we're going to start here. We'll imagine that we're facing that direction with our arm. So our first turn is going to be this one, and then we're going to walk to here, and then we're going to turn this way. Then we're going to walk to here, then we're going to turn that way. Then we're going to walk to here, then we turn that way. Then we're going to walk to this point, and then we turn this way. Then we're going to walk to here, and then we turn that way. And then we walk to our starting point, and we end up facing the same direction that we started with. And now what we could do is if we did this same thing and we add up all of these exterior angles, we would still find that they all sum to 360, to one full rotation. And what you can do is see how accurate you can get these exterior angles. Use a ruler to draw the lines, right? Be very careful drawing your angle measures and see if you can see how close to an actual circle in freehand drawing you can make your angles. If you're very careful about it, your drawing will look pretty close to an actual circle. So I highly encourage you to do that. Going through this visualization has really helped to cement this concept in my own mind. Now, this only works for simple polygons, and what that means is that the sides of the polygon can't intersect. So for example, if we have a pentagon, 1, 2, 3, 4, 5, that doesn't work. And it doesn't work because there is an intersection. The sides intersect. But as long as we're dealing with simple polygons, the exterior angles will always sum to 360. So really two big intuitions to take away from this. The first is the difference between an interior and an exterior angle. And all an exterior angle is that when we have a figure here like our polygon, and we extend one of the sides like we've done here, the exterior angle is the angle between that extended side and the adjacent side. So in our case here, it's this red angle. And then the interior angle is the angle between two adjacent sides. So in our polygon here, it's this angle here. That's the interior angle. The other big takeaway is that when we're working with a simple polygon, like in our case here, a triangle, the sum of all of the exterior angles will always be 360. And remember that visualization of starting with your arm pointing in one direction and walking around the perimeter of the shape. That helps me to remember this 360. It's always one full rotation of a circle. So I hope you find that visualization as useful as I do. Make sure to like, comment, subscribe, share it with a friend who needs to see this, all that good stuff. Have a wonderful day, and I will see you next time. Bye!